everyone, this is mathematics. We solve this question now. The question is saying find the coordinates of the points on the curve where the gradient is 0. Okay, before we go any further, this is we are going to use Rolle's theorem to solve this question here. So with the theorem, Rolle suspected that if a function is differentiable and it crosses the horizontal line at least at 2 points, there is at least one point where the tangent to the graph is 0, and it is at that point where the gradient is 0. Okay, so let me illustrate this. So what he meant is, let's say we have our x or y plane. This is y, this is x-axis. And he stated that if a function of okay, we have f of x there, then this function is differentiable. Okay, so that means to say dy dx of this function, which is f prime here, like this, then, and this function, it crosses the horizontal line at least at 2 points. Let's say we have, this is our function here, this is our function, it crosses the horizontal line at A and B. Okay, this is f of x, this is our function here. So the theorem stated that if a function is differentiable and it crosses at least at 2 points of the horizontal line, then there is at least one point where the tangent is horizontal, and at that point the gradient is 0. Okay, so that means to say we can clearly see that at this point here, if we draw the tangent to this curve here, this graph here, so this is the tangent. So you can see that this tangent here is horizontal, and at this point here, if we want to find the gradient, it means the tangent at this point here, it is 0. So the gradient is 0. So that is what Rolle's theorem states. So at this point here, we know that dy dx is equal to 0. Okay. So we solve the question now. I hope you have understood the theorem. Okay, the original function that we have is y is equal to x to the power 3 minus 3x squared minus 36x minus 3. This is the function that we have, and we have to find the derivative of this function. So finding the derivative of this function, we have to differentiate. So this gives dy dx is equal to, we know how to differentiate. This is 6x raised to the power 2 minus 6x minus 36 here, and this is the derivative of this function here. So we simplify this derivative here because it has it can be simplified here. So we say divided by 6 throughout this equation, and we know that this derivative is equated to 0. Okay, so that means our derivative is okay. So we can see that it is this derivative is simplified, and we can easily factorize, or we can easily find the x values here. So how can we find the values of x, or the two values of x? Finding the two values of x, as the theorem stated, or as the question is saying that where the gradient is 0. So this equation that we have here, it is the equation of the gradient. So we have to equate this equation to 0. So as we have done here, you can see that this equation is equated to 0, and this is a quadratic function. So finding the x coordinates here, or the two values of x, so we can use three methods to find the values of x here. We can use factorization method, where we have the product sum, or we can use completing the square method, or we can use the quadratic formula. Okay, so in this case here, my choice is using the factorization method. Okay, if we use factorization method, we know that the product sum, we know that the product is -6 and the sum is -1. So the factors of 6, when we multiply, we need to find the two factors of 6. When we multiply them, they give us -6, and when we add them, they give us -1. So the factors of 6, we know that we have 6 itself, we have 3, we have 2 and 1. So if we decide to get 2 and 3 here, we say 3 multiplied by 2, this gives us 6, and 3 plus 2, this gives us 5. So this shows that one of these factors must be negative. Okay, so if we say that 3 is negative, and we multiply here, we are going to get -6. And when we add -3 plus 2, we get -1. Okay, so that means 3 is negative and 2 is positive. So we replace with this. So this gives us x squared minus 3x plus 2x minus 6 is equal to 0. So we can factorize here. We have the common element here, which is x. So x here, x minus 3, and plus 2 here. Then we are going to have x minus 3 here. So we have x plus 2 and x minus 3. So we equate this to 0. So we can clearly see that x plus 2 is equal to 0, and our x is equal to -2, and x minus 3 is equal to 0, and our x is equal to 3. Okay, we have found the two values of x. So the thing that we have to do here is we need to find the values of y. So finding the values of y, we need to use the original equation here, and then where there is x, we are going to replace with the values of x here that we have found. Okay, so let us write our x coordinates here. We have x is equal to -2 and x is equal to 3. Okay, we have these two. Then we have our function there. Okay, so continue. So let's say we want to find the value of y when x is equal to -2. So when x is equal to -2, okay, y is equal to 2. This is -2 here raised to the power 3 minus 3. We have -2, we have raised to the power 2 minus 36, minus 2 here minus 3. Okay, So for this one, we know that this is negative 8 here, negative 8 multiplied by 2, that is negative 16. And this is minus 12. This is positive 72 minus 3. This gives us this and this, the add, that gives us this and this gives 8, and this is 2. So the negative 8 minus 3 plus 72. So this is negative 31 plus 72. Okay. So this means that our y value here, if we subtract, we get y is equal to 41. So we have the coordinate where we have negative 2 and 41 here. Okay, the other coordinate when x is equal to 3, so we say when x is equal to 3. Okay, so when x is equal to 3, we replace in the equation here. So we have 2, this is 3, this is minus 3, this is 3 here, and this is 36 here, and this is 3 here minus 3. Okay, this is 27 here, 27 multiplied by 2, that is 54. Okay, minus this is 9, 9 multiplied by this is 27, and this is 18. This is 18, this is 9, so 108, then minus 3. Okay, so we can add this is 54 minus 30 minus 108, and this gives us 54 minus 138. Okay, so we subtract here, we get the value of y, which is, this is 4, this is 4, and 13, negative 13 plus 5, that gives us 8. So this is negative 84 here. So we have the coordinates where we have 3 and negative 84. Okay, so we have found the coordinates where the gradient is 0. So these two coordinates here where we have negative 2 and 41 and 3 and negative 84. So these are the coordinates where the gradient is 0.